today I'm going to be talking about immutable web apps, what they are, how they came about, and why they make our web deployments a little less risky. So about me, my name is Andy Damaris. You can find me pretty much on any social media platform as Teradox with 2 O's. My website is teradox.tech, and I'm currently an employee at Meltwater. So what we're going to cover in this talk is a little bit of background about how we arrived at the Immutable Web Apps philosophy, how simplifying builds was a really critical part of that. We'll talk through the anatomy of what an immutable web app actually is. And then we'll talk about an example of how we could use NPM and unpackage in a creative manner to solve one of the problems that immutable web apps bring to light. And then we'll talk through how I use it on a day-to-day basis with the team that I work on at Meltwater. So the company that I work at, Meltwater, started about 6 years ago with a very monolithic application, like many people did back then. We had a monolithic front end that many teams were contributing to, no real way to define who owned what, very brittle releases, and it started us on a journey. So that journey sent us from trying to figure out this single monolithic code base with month-long release cycles where we would have a week code freeze every month where we wouldn't be able to contribute any code just to make sure QA had time to QA it. And then we would go through a release cycle with our ops team where our ops team actually did the code releases and things like that. And we had to be kind of hands-off, long regression cycles, all of the pain of a traditional waterfall type approach. And today we're now many front ends. So we have a pretty good micro front end architecture at this point, where we have many teams releasing multiple times per day for our front ends, and most of them are doing it with their self-controlled CI/CD pipelines. So we've taken a big leap from this monolithic waterfall approach to a very micro front end, very agile approach. But along that journey, we kind of came up with some questions that we really felt like weren't being answered very well at the time. And the biggest thing that we were looking to do is make our deployments as absolutely safe as possible. So we came up with some goals that we wanted to achieve as a part of this. And the first goal was that we wanted to eliminate as much variability as possible between our deployed environments. We wanted our test environment to look as close to our production environment as we possibly could. We also wanted to make deploying a very atomic action, something very simple, where there was one thing that was changing, and that one thing was dictating what was out in production versus what was out in staging. Along with that, we wanted to make sure that our rollback system was lightning fast. So if we detected a problem in our initial smoke testing, we could roll back to our previous version very quickly and get that time to recovery down under a minute or 2 minutes if possible. We also wanted to increase awareness of which version of the code was being deployed at any given time. One of the things that we noted is that things like hashed files didn't really help us understand which version of code was in production necessarily. So along that thought process of simplifying deployments, one of the first things that we really aimed to do was move our environment variables outside of our JavaScript bundles. Environment variables are the biggest thing that change between a testing environment and a production environment. So we wanted to make sure that those things were isolated away from our JavaScript and our business logic. And much like you would do with a Docker style deployment, keep all of our environment variables isolated from the rest of the code. So the way that we achieve this with our front-end deployments is we actually use the window or the global this variable to hold all of our environment-specific configuration. That means that any of our URLs that we need, API keys that we need for those types of things are all on the window instead of being baked into the JavaScript bundle. This also yielded that we could build our bundles once, and we only had to do that once for each version of the code base. So for version 13.8.2, there is one bundle that corresponds to that particular version. And as I just kind of hinted at, using semantic versioning can make that a very clear understanding of the type of change that's about to be deployed. So if your current version of your index file is referencing version 12.8.2 and you're about to roll out 13.0.1, you know that there's a major breaking change in there somewhere that you need to be mindful of and considerate of as you're deploying out to production. So what are we gaining with all of this? We're kind of gaining two major benefits that we'll dig into more deeply. But the first one is that we're gaining immutable assets. When we build our JavaScript bundle, we build it one time for that version, and then it's kind of chiseled into stone. We don't have to worry about rebuilding for that particular version of the code base ever again, because we shouldn't have to. That is now locked in place. The other thing we gain is atomic deployments. Because we've removed all of the environment variables out of the JavaScript and into a single location, in our case, the HTML file, we now have that one thing that's being deployed. So let's talk about immutable assets a little bit more deeply. So no environment-specific context in the bundle. That allows it to be built a single time. Then we publish it to a unique location. Typically, it's a folder based on the current semantic version. The value of doing that is that we can now cache that file from a user caching and a CDN caching perspective as permanently as possible. So with browsers, that's about a year. So we set our cache headers to be a year for all of our immutable assets. It also means that we get to use the same bundles in every single deployed environment, all the way from a development environment to a test environment to a production environment. We're using the exact same JavaScript bundles. So we know that that code, much like you would do with a Docker image, is really set in stone and not going to be moving as you're testing between environments. The second one that we talked about was atomic deployments. Since all of that environment specific information is now isolated to our index file, we now know that that index file is the one spot in our application that we never cache. It's the one point that we always need to keep flexible to be able to do rapid deployments. So by not caching our index file, it means that the second that we publish a new version of our application and a client refreshes, they're getting the new version out there immediately. We also know that our immutable assets are already available because we would have validated all of those immutable assets in a test environment to make sure that they're running and available as expected. So releasing to production is now that atomic change that we were hoping for. It's a single file, our HTML file, that moves between our testing environment and our production environment as we're rolling out. So the last bit that I wanted to hint at, that's kind of hinted at in that atomic deployments, is rollbacks. Rollbacks can be kind of scary if you have a really complex environment with a lot of moving pieces where there are several different things that have to change in order to roll out. Rolling back means there are several different changes that have to happen to roll back. Rolling back with an immutable web app approach kind of simplifies all of that. Now we just we revert the changes that were done to that index HTML file back to what they were prior to our deployment. You can do that manually, but with a source control system in place and a CI/CD pipeline, it's even simpler. It's literally just reverting our last commit. So getting back to a previously stable state is now something that we can do very, very rapidly from a source control perspective without having to jump through any manual hoops. So a very, very powerful tool that's been put in place. So let's talk through what the anatomy of an immutable web application actually is. It's really comprised of three main pieces. So those pieces are a deployment manifest, in our case, an index HTML file, our immutable immutable assets that are all of our JavaScript and CSS assets that should be in fully qualified URLs, and our APIs. So our APIs are not only the actual APIs themselves, but also all of the environment variables that go along with making those APIs function appropriately for the different environments that we're in. So we're going to dive into each one of those pieces right now. So the deployment manifest. This is our index HTML file, and it's unique for each environment. So our test HTML file is going to have very, very different contents than our production HTML file will. It's also never cached by the browser. This is the mechanism that allows us to have those instant deployments where we push out code and they should be immediately available to our customers the next time they refresh the page for our application. It also contains all of our fully qualified references for our version static assets. So all of our JavaScript and CSS in their fully qualified version folders, all of our globally scoped environment variables. So things like API URLs, API keys, any feature toggles that we might have going on for that moment, and any browser metadata that's specific to that application. This is also typically served from a static web server, but also fronted by a CDN. And it's interesting that I say fronted by a CDN because traditionally we think of CDNs as being a caching layer. And what I've just said is we never want to cache this file. CDNs play a bit of a different role when it comes to our deployment manifest in an immutable web app scenario. They really play the role of resiliency and rapid time to first byte if possible. So at the edge locations of our content delivery network, the natural way that things should work is a client requests it, then the CDN requests it from origin. And when the origin responds, the CDN can keep a local cache of that and then respond out to the client. But we tell our CDNs not to cache because we want them to get a clean version of it every single time it's requested. Well, sometimes things go down. So let's say that you're hosting your static index page on Heroku, and that Heroku instance is just not functioning for some reason at that moment. The CDN still has the ability to serve its most recently fetched version of the index page to make sure that the customer is still receiving something that's functional, even though our backing instance that we really want to be serving from is down at the time. So that additional layer of resiliency is really why we want a CDN in place in front of our deployment manifest. On the immutable web app side of things, we really want to be serving this from a different location than our web application. And different location can mean different domain, different subdomain, or even just a separate route on that domain. But the big deal is that we get that into organized and versioned locations because that is really critical to getting our long cache lifetimes. This is a small example of what that might look like. So you can see the URL with the fully qualified version of 1.2.3 in it. That's really kind of the critical crux of all of that caching stuff that we're talking about. Because if we only did, for example, a major version there, when we rolled out a new minor version or patch version to that major version, we couldn't have that long-lived cache header. We would have to be refreshing that file more often. This is also typically served from a static web server. Something as simple as like an AWS S3 fronted by a CDN, or NPM via Unpackage is another example of how we could do this. And we'll dig that more into that later because it's a very, very interesting use case. The big deal is that the web server should definitely be fronted by a CDN, and all assets should be configured for very long-term browser caching. So the CDN really does play a critical role in this case. So when we publish out a new version of our assets, the CDN is going to be holding on to those assets permanently, because as with everything that we've set up till now, they're immutable. They're never going to change for that specific route. So the CDN can hold on to those assets permanently. That means that we're going to have extremely rapid load times for everyone after that first person to hit an edge location on the CDN to be able to load all of our assets in a very, very timely manner. The last piece of our immutable web app anatomy is APIs and environment variables. So our APIs should be, again, available from a different location than the web application. And this is purely just for debuggability and readability and logs and things like that. And that could be a different domain, a subdomain, or even a route on the same domain. But the big deal is that if we're serving from a different domain or a different subdomain, we need to be very, very mindful of cross-origin resource sharing. So at the company that I work at, we actually serve our APIs from a mix of other domains. And that means that we need to be ensuring that those are configuring the options method for each of the endpoints that we're hitting appropriately, and making sure that that options method is responding with the appropriate headers to allow all of the verbs that we need to hit those endpoints with, and allow the appropriate domains that we're coming from to be served by that API appropriately. I know we've probably all, either ourselves as a full stack developer, or if you work with a backend team, run into the obnoxious CORS error on the front end that really is kind of opaque. And that's purely because of that options method configuration and those headers being configured appropriately for hitting cross-domain APIs. So I'm going to take a breath here for a second, grab a quick drink of water. And the next thing that I want to jump into is how immutable web apps and NPM can kind of play together to solve one of the big things that we kind of highlighted in our IWA architecture. So one of the things we said is that we really need those immutable assets. One of the things that NPM is actually perfect for is guaranteeing the immutability of assets. It guarantees version safety. So we know that if we upload a specific version like 1.2.3, then that version can only ever be published once to NPM for that package. Once it's published, NPM refuses to allow you to publish over the top of that existing version. It also can't be removed from NPM. So once you've uploaded it and you've passed the I think it's like a 2-hour window that you're allowed to revoke a published package version. Once you pass that 2 hours, it can never be removed from NPM. It can only ever be deprecated. And that deprecation doesn't remove any files. It just says, it has a notice that says, this particular version of this package has been deprecated. So we get that guaranteed immutability of assets by using NPM as the place that we hold our assets. The other part of it is that NPM is a very natural deployment location for JavaScript code. NPM publish is built right into our tooling to be able to publish directly to the NPM registry from where we're working. We're already using it to do our package installs and our package updates, probably also really using it to do some of our build commands using NPM scripts. So NPM publish is right there at our fingertips as a way to do very, very simplified deployments. But NPM only kind of solves part of this. It solves the immutability aspect of things. How do we get that exposed to the web? And that's where unpackage comes in. So unpackage is an HTTP front for NPM packages. So it basically gives you a logical way to get your NPM package available to the wider web. They have the ability to have fully versioned URLs, and they are fronted by a CDN. Currently, they're fronted by Cloudflare, and Cloudflare has many, many great points of presence around the world that we can take advantage of with this system. The other nice thing is, much like we've stated earlier, they automatically cache those fully qualified version URLs for the full length of time that you can, which is currently 1 year on the browser side cache. So they've kind of checked all of the boxes that we've been talking about with our immutable assets. So between NPM and their version safety guaranteeing immutability, and unpackage giving us the HTTP front to that immutability, we now have a system that we don't need to manage any infrastructure for to get our publicly facing assets out and available. So I will talk more a little bit about how Meltwater solves our private information problem, because not everything that you have hosted you want necessarily available through NPM publicly, but we'll get to that in a little bit. So the nice part of that is that now that we're using all of these publicly available pieces and everything is available for us, the only thing that we now have to host is HTML files. And those HTML files are nice and simple. We use the immutable assets hosted via NPM and unpackage, and we can host our files as on something like S3 or even GitHub Pages as an example. If you're just doing something really straightforward and it doesn't need all of that like high level of availability and guaranteed everything, GitHub Pages can be a really simple way to host your index.html file with all of your immutable assets being hosted via unpackage and NPM. It simplifies all of that infrastructure that we would have to be managing on our own into a very, very straightforward system for deployment. So what does this look like for our anatomy of an IWA? Really, it's that central piece, the immutable assets that we're swapping out. You can see that in our diagram, unpackage is kind of taking the place of our own custom hosted solution, and using unpackage solves the immutable asset portion of the question. So let's take a minute and let's see this in action. We'll take an example from where I currently work right now at Meltwater. I'm going to just minimize this. Here we go. And we'll start with looking at code here real quick. So I'm going to start with how we break up our deployment system. So for the team that I work on at Meltwater, we break up our deployment system into 2 separate repositories, actually. So we have an assets repository, which hosts all of our JavaScript bundling information, and we have a web repository. And the web repository holds basically just the index page. So what you're looking at right now is our assets repository. You can see it looks just like you would expect an NPM package to look. In our case, we actually publish to a private namespace. We have an @Meltwater namespace that is a private namespace that we publish to. And this current package is up to version 36. We had a lot of breaking changes cycle through this, but that's okay because we use semantic versioning to notify those things. Outside of that, it looks like a very standard NPM package. We on our team use NPM ignore to limit the package contents that are published to NPM during our publishing process, to make sure that we're only publishing the assets that we really care about. But in our source directory, it looks like a pretty traditional web application. We have components and services and translations, and not a whole lot else. So this piece gets published to NPM, to our private namespace within NPM. And once that's published to NPM, we can basically install that package as a dependency to our web application, and then we can use the package JSON as a manifest file for what the version of these assets that we need to rely on in our index page actually are at the time of publishing. So in our index file, if we scroll down here, we can see at the very bottom, we have an assets URL, and then this variable that we use during our build time, which is the version being read from the package JSON, to create our URL for where our static immutable assets are going to be available from. So it really makes deployment out to production a lot more straightforward, where we can use the package management systems that we're already comfortable with for managing third-party packages for our own internal packages and our own internal deployments. The other thing you'll notice in this index page is that we have all of our environment configuration that we need for all of the different pieces that we're actually deploying available. So there's environment variables here for some things, which environment we're actually running in, a logger ID, the application name, those types of things. Also, as complex as API keys if we need them. So we keep all of this in static JSON files for the different environments that we deploy to, and we just use Mustache to populate those things at deploy time for each of our different environments. So it keeps things reasonably straightforward. Let's see what this looks like in an actual browser. So this is the application. It's a dashboard that has a lot of different metrics on it. Nothing really specific about this dashboard other than it's based on my micro front-end architecture that's a little bit different than some use. We use web components to do most of our building. So that means native JavaScript web components are powering pretty much the entirety of this page. Each of these analytics is actually a separate package, all based on immutable assets going into our private repository. And the great part about that is that this is a secondary page load. It's not a first page load. But if we actually look at what the network looks like for all of these assets coming in, you can see that the vast majority of them are actually coming from either the memory cache or disk cache, which means that there's no overhead to get this data available to our page immediately. And that means that refreshes are usually sub-second, even for a large volume of JavaScript that we need to power all of these custom analytics. It also means that we can use a mixture of unpackaged, like this is being served from unpackaged, it's moment.js being served from unpackaged, and our internal version of unpackaged that we call mpackage. So with mpackage, it has a very similar URL structure. It's just our own URL with mpackage and a fully qualified version. We can still achieve that high level of caching where we're setting our access control max age to, if we take this and drop it over to the console and just do a quick bit of math, if we divide this by 24 for the number of days, 60 for the number of minutes, and 60 for the number of seconds, it's 365 days. So we're caching all of these assets for that full year that we talked about, so that as clients come back over and over again into our application, they're not really downloading anything except for exactly what's changed, which is the index page. So it keeps our assets really, really rapidly loading. So jumping back into our presentation, let's just summarize everything that we've gone over real quick. So in a nutshell, immutable web apps, the biggest part of the philosophy is isolating that configuration that we need for all of our different environments from the business logic that we're building with each of our bundles. These assets then get to be built once and published to a unique location for that package version. Unpackage, as I demonstrated, is a great solution for this because NPM guarantees that immutability, and unpackage guarantees that high level of cacheability that we need. And then our index HTML page becomes our atomic unit of deployment. So when we're pushing something out, there's one building block that's dictating everything that's being deployed. So when we have to roll back or we need to roll forward again, we know exactly what's changed, how it's changed, and why it's changed in a single location. And all of that environment-specific configuration lives in that index HTML file, so we can see all of the pieces that are actually the variables between our different environments. So I covered quite a lot, but I would love to field any questions that you might have.